we invited Luca Chiodini from USI. He did research on programming misconception, and he will talk about that today. So Luca is a researcher and PhD student at USI, and I'm not going to try to pronounce this Italian full name, but he can do it himself later on. And he has research interest in effective education and good teaching, which fits what we do very well. And the reason why I invited him to give a talk today is because he is the author of a paper on a curated inventory of programming language misconceptions. And for that paper, he and some of his colleagues created a website called Proc Miscon, and he will talk way more about that as well, which basically is a very practical inventory of those misconceptions that can be very useful in your education as well. So without further ado, and I'm very happy he is here, Luca, I'm going to give the floor to you. You can start sharing your screen. And if anyone has a question, you can let us know in the chat and we'll interrupt, or you can interrupt them yourself. All right.
All right. So should be sharing now?
Yes.
Great. So as you said, perfectly, even without pronouncing Università della Svizzera italiana in fully. That's our setting. That's where we come from. But this paper specifically that was presented at ITICSI this year is actually an international collaboration between this university, my home university, and a university in Canada, where Professor Hania Tafljevic comes from, and University of Lisbon, where Professor André Santos works. So this is a collaboration of the authors you see on this title page. So let's dive in and let's try to understand why we're building this inventory of programming language misconception and what a programming language misconception is in the first place. We want to start with an example. This is in Java, but I'll try to walk you through the examples that you don't get lost, even though it might not be your favorite programming language. We are defining a class student with two fields, first name and last name. And then we write a pretty standard constructor for this class with two parameters. And then in the constructor, we are assigning the two parameters to the two fields of this class. And that class might then contain a bunch of other methods which are not of interest here. And suppose that now you assign a task to one of your students, like, for example, to use this student class from this main class. On these two lines here, we are instantiating two objects of this class. So here I'm instantiating new student with my first name and my surname, and I'm storing a reference to this object in the variable S1. And then I'm doing the same thing here in the next statement, and I'm storing a reference to that object in the local variable S2. And then the task for your student is to fill in this condition here in the if statement so that it prints same student only when the two objects represent the same student. And oftentimes when you you assign this task to your students, even after explaining objects, references, classes, comparison, equality, what they are going to do is they're probably going to write S1 equal S2. So they are going to compare the two references instead of comparing the two objects and doing what it's called or known as structural equality of objects. And so this is not going to work because the two references point to two different objects in the heap, even though the two objects logically represent the same student. Now, if you're an experienced teacher, you might wonder, why does this happen so often? Why do students keep repeating these mistakes? Why don't they learn programming in the right way, even though we explain things, or we think we explain things in the right way? And well, our struggles are shared in history. It's well known that programming is hard to learn. And this goes back to A well-known example is the rainfall problem. And it's a very simple problem in which students are asked to write a program which repeatedly reads in integers until it reads a special value as a termination condition. And then after seeing that special value, the program should print out the correct average of those numbers, which should represent the rainfall amounts in a given place. And so it should not count, of course, the terminator value. And this problem was conceived by Soloway in 1983, and he gave that problem to students in top US universities such as Yale. And he found out that a surprisingly low amount of students after their CS1 course could actually solve this apparently simple problem. And this really showed that programming is hard and we better improve the ways we teach to program. Now, if we go back at the question of why programming is so hard, well, we can at least think at two big aspects for that. And you need to have two prerequisites for being able to effectively program. Well, one is what is known generally as the ability to abstract. So you have a concrete situation, you have an example of a real world scenario, and you want to abstract. You want to create a model of that. You want to create a program that somehow does some computation. And then you need to have some specific knowledge on how to write those programs, because you can't write programs without having a programming language and in various ways. And for knowledge is the aspect that we will be focusing on for today. So the knowledge that is required to program. And this is one of the many literature reviews that have been done on the topic of knowledge for programming. This is from Kian and Lemma, 2017. They reviewed a lot of students' misconceptions and difficulties in general that students have in introductory programming. And among many other things, they divide the knowledge that is required for programming into two aspects. One is the conceptual knowledge, that is the syntax and the semantics of the programming language you are using to program. And the other side, when you know the syntax and the semantics of that language, you also need to have some strategic knowledge. That is, you need to be able to apply and use the syntax and the semantics in a specific domain and problem, and that's called the pragmatics. And that's a super interesting and wide area, which maybe has not received enough attention, but it's not our focus for today. So our focus is really specifically on the conceptual knowledge. More specifically, let's try to understand one of the many perspectives. This is just a small hint. The literature on knowledge is incredibly vast, and I'm not the best qualified person to give you a concrete perspective on everything that needs to be known on the subject of knowledge, but this is just a small primer. One of the many perspectives that has been popularized by DiCessa is the so-called knowledge as elements perspective. That is, we acquire knowledge, or we can view knowledge as many pieces that we acquire and we store in our brain. And of course, those pieces of knowledge are interconnected and deeply interlinked among each other. And when you have a lot of these pieces, when you set out to learn a new topic, the key observation is that we always bring some prior knowledge. We already have some of these puzzle pieces I represented there in our brain whenever we attempt to learn something new. And well, there are at least 3 cases when we try to learn something new. Well, and then somebody tests us. It could be that the conception we are going to test is not there. The student simply has not acquired that conception. Or it could be, and that's the very good case, in which the student has perfectly acquired this new puzzle piece, and you see it's perfectly interlinked with the previous puzzle pieces he had in his or her mind as the prior knowledge. And that's the ideal scenario. But unfortunately, that's not often what happens, because oftentimes students learn a conception and they learn it wrong for many, many reasons. And so this new piece of the puzzle is not going to fit well with all the other pieces that were previously there. And these wrong conceptions that students have and that then use, for example, to program in our domain are often called misconception, as in erroneous conceptions. Now, our goal as educators is oftentimes to discover that students hold misconceptions, so they have this red, not connected piece of the puzzle, and we like to bring them to the correct conception, to the ideal scenario. And this process is known in the learning sciences as conceptual change. This is what ideally every teacher should try to do, should try to induce conceptual change in their students. Now, back to misconceptions for programming, which is our domain. There has been a lot of research in the field of programming misconceptions. These are some of the definitions that can be found in the literature that try to define what exactly are those programming misconceptions. The first one comes from Smith that says they are student conceptions that produce a systematic pattern of errors. The other one comes from Sorva's dissertation. He describes programming misconceptions as understandings that are deficient or inadequate for practical programming contexts. And the last one comes from the review that I cited earlier, that there's misconceptions are just errors in conceptual understanding. And of course, each of these definitions has its own merits, but they're not really exactly defining what a programming misconception is. Of course, because it's a somewhat hard task to really delineate the boundary of what is or is not a programming misconception. The problem is that if we want to create an inventory of those misconceptions, we better define what exactly is or is not in that inventory. And so these are some of the lists of misconceptions that can be found, two very famous ones. The left one comes from the appendix of Sorva's doctoral dissertation, and it contains more than 160 misconceptions. And the other one is a popular website from Colleen Lewis, csteachingtips.org, that contains some content in her website that is tagged with the label content misconceptions. And also there are a lot of misconceptions. The problem with these lists is that Sorva himself writes that this is an incoherent list. This is a list of not only apples and oranges, but also of tomatoes and the odd dried plum. So there is clearly a problem in trying to define what exactly is in this list and what is outside this list. Now, if we just focus, as I was telling you earlier, on conceptual knowledge, I think we can provide a better definition for what is a misconception, or better, a programming language misconception. Since we are just focusing on the syntax and the semantics, we restrict ourselves to the programming languages domain. And so this is our attempt to define what exactly is a programming language misconception. We came up with this definition. A programming language misconception is a statement that can be disproved by reasoning entirely based on the syntax or the semantics of a programming language. This is our definition, and I want to highlight at least two key aspects of it. The first one is that it's a statement, so something that a student, for example, might say, and it has to be a falsifiable statement. That is, based on the syntax and the semantics of the programming language we are teaching, we must be able to falsify it. The other part is that it needs to be about a programming language. If it's about computing in general, that's maybe an interesting misconception, but it's not in our catalog because it falls outside the programming language's misconceptions. Now, we can review a couple of examples from Sorva's list to see whether they fit or they do not fit our list. The first is this one. A set, such as a team or the species of birds, cannot be a class. This is actually not a programming language misconception according to our definition, because it's not tied to a programming language it's a general issue that students have with modeling the domain in object-oriented programming with classes. The other one is about a programming language. We assume that, for example, this could be about Java since it talks about constructors, but stating that students have difficulty in understanding the empty constructor, that's not a falsifiable statement. We can't really disprove. We can't say whether this is a true or a false sentence because this is a general description of an issue that students have. And instead, we try to write all our misconceptions as falsifiable statements. So one can really say, well, if you say this is really wrong. This is not true according to this programming language. And so with all this knowledge, we have been trying to build progmiscon.org. It's a growing website. I'll now highlight what's in there and how you can best use it. So let's take a look at, as an example, I will bring more than one example, but let's start with this one, which refers to the misconceptions students had with the example I presented at the very beginning. This talks about the equality operator in Java. And here is how the page looks like. It is very rich. It contains a lot of elements. One important one is the title. So we have been trying to give a memorable title to each misconception, like design patterns, so that it can be referred with a specific name, in this case, the one at the very top. Then we have this idea of having the statements. So the red one is the wrong statement that describes the misconception. In this case, that O = P compares the objects referred to by the variables O and P. And we have also the right-hand side of that, which is the correct statement in the green box, which is the correct sentence. So that O = P compares the references stored in the two variables. And this idea of having the incorrect statement of one side and the correct statement on the other side is a well-known idea in the learning sciences. It's called refutation text, when you compare and you juxtapose the two texts so that you are trying to induce conceptual change. And we do this in two different modalities. One is in the text, in the two boxes, and the other one is in the images. So the images often contain some small snippets of text and maybe some diagrams, some notional machines, in this case, a memory diagram that tries to represent what's in the stack and what's in the heap and tries to see what exactly we are comparing with that operator. And then we have a rather lengthy description of the correction, so that describes what exactly is right according to the language specification. I'm not showing it in its entirety here. We are tying this to the programming language specification so that one can really see that this is not just our opinion on how things work, but we're really referring to the official specification. We tagged each misconception with concepts. In this case, we can see that this one talks about equality, references, objects, values, operators, and expressions, so that then I'll show you later how we can use these concepts to easily browse the catalog. We also index each misconception by some notional machines. For example, this is a memory diagram, a stack and heap diagram. And so it's a way to diagnose the fact that students might have these misconceptions. And we have a page that describes a couple of notional machines that can be used to bring up this sort of issues and to explain or ask students to explain their code using those notional machines. For example, this is one of the ones we use, a stack and heap diagram with a sort of rich notation. We have interconnected misconceptions so that we know that errors do not occur in isolation, that students sometimes have this kind of misconception, and then they oftentimes have also these other misconceptions because they are related not only in terms of concept, but because they are somewhat really closely related. And so we encoded this fact in the related misconception section. And we also know that misconceptions do not occur in a single programming language, but oftentimes the same misconception occurs almost identical, maybe with slightly different terms, in another programming language. For example, we see that in JavaScript, we have the exact same misconception we have here. More on this misconception, we try to track down where possible their origin. So we see where the misconception could come from, where could the students have learned to think this way. Some symptoms, so sometimes students hold a certain misconceptions and then they do things based on having that misconception. For example, in this case, it's quite simple, but in some other cases, it's very rich. They can do a lot of things, a lot of weird things, and these are kind of ways you can observe or probe the fact that they have this misconception. And for some of them, we even have some videos of real students that we recorded in a kind of experimental setting that have some misconception. For example, this is a JavaScript misconception, the fact that a constant reference implies the immutability of the pointed object. And here is a YouTube video. So if you go to the symptoms section of that misconception, you can see the YouTube video. And you really see a real student with the transcription that is trying to solve an error and does a mistake, which is probably a good symptom of him having a misconception. This is yet another Java misconception, the fact that parentheses are only required if there are some arguments, whereas they are mandatory even for method calls that do not have any arguments. And this is interesting because we have value. So if you teach more advanced concepts, like, for example, higher order functions, you could build on basic misconceptions to explain even harder concepts in later courses. And so even misconceptions that seem purely superficial, like a student that has just forgotten to put parentheses after a method call, they could provide an opportunity to discuss even some advanced concepts. So this is a thing you might want to keep an eye for. And then where possible, we also tie this with other papers, so published literature that talks about the same misconception. And so we try in this way to connect research papers. Now, very much concretely, I want to show you an example of how you could link to progmiscon.org in CodeGrade. Before that, I would like to mention that we now support 3 main programming languages: Java, JavaScript, and Python. Our initial focus was Java, so that's the most complete collection, but we have been trying to expand, especially the Python one. We have a collaboration, as I said at the very beginning, with a professor in Canada. And so there, they really have a lot of students, and they're trying to collect and document a lot of information about Python misconceptions. So you might expect that content to grow significantly over the next month. Here is an example of a piece or a fragment of a student solution taken from CodeGrade. So it's just the student is iterating over a list of numbers, and it's trying to do something based on whether the number is a digit by calling the isDigit method of number. And then it's comparing this with the false literal value inside the if. And this is actually one of the misconceptions. This could be a symptom of a misconception we actually document. This is the fact that one always needs to compare what is already a Boolean value with a Boolean literal to actually produce a valid Boolean expression. That's really not the case. I mean, a Boolean expression is a Boolean expression in itself, and so it's already being evaluated to a Boolean value. There is absolutely no need to further compare these by using a Boolean literal. And the page describes it as a quite lengthy explanation on why it should be preferred to avoid this unnecessary comparison, but not really just for the sake of writing less code, but really for having students profoundly understanding what is an expression and what is the type of an expression, and the fact that each expression evaluates to a certain value. Devin, you might want to step in and explain how you could integrate this directly into CodeGrade.
Yes, thanks, Luca. So what Luca and I discussed before is that some of the misconceptions that you can find on progmiscon have not only very valuable information for teachers, but also have information that is very understandable and very valuable to students as well. Just like Luca just mentioned, that they can give students a deeper understanding of why something that seems so trivial, like comparing it with just false, like we see in this example, is an actual misconception and should be looked into further. So what you can do, of course, inside CodeGrade, and all of you probably are familiar with that, is save snippets. And if you already have some snippets, it is very easy to just add a link to the misconception in the database of Luca, procmiscon.org, in your snippet. And since we also have Markdown in there, you can just save it and the link will be clickable as well. So for instance, right here, we have an example snippet where we first tell the student why this is a problem and what is the problem. So in this case, it can be simplified, it should be simplified, and it already is a Boolean value there, so you don't need to compare it with false. And then we just add the link to the programming misconceptions so the student can do some additional reading if they think that's useful. And if you already have some of your snippets ready, something that could be useful, especially in maybe introductory courses or programming too, is that you add some of these links to your snippets for programming misconceptions that you think are valuable for the students to read more about. Cool. So that is a practical thing you can do inside CodeGrade. I'm going to give the floor back to Luca now, so he can keep going and share more.
Yeah, yes, that was very, very spot on. So I just want to kind of wrap up by saying that you can definitely contribute to the inventory or get in touch with us if you have ideas how to further develop this, either in terms of adding new content or documenting new misconceptions, or you maybe want to integrate this. We have, if you are more keen on programming and you want to embed, for example, some of our content into your website, we have a static API, and you can also even use iframes to embed our content. But if you just want to get in touch with us, you can enter our Discord, or you can drop us an email. You can contact us on social media. There are various ways described in the page of how to reach us. And finally, I would like to show you 3 practical ways in which you can navigate procmiscon.org to get the most out of it. The first one is you can browse misconceptions by using concepts. So here is Progmiscon, our website. You can click on the concepts tab, and here you can find a list of all concepts. And you can click on each of these concepts to see the misconceptions that have been tagged with these concepts. For example, if you are about to explain or you have already explained assignment, then you can really see that assignment, for example, in Java, you can filter out and you can see that there are these misconceptions specifically for Java and specifically for the concept of assignment. And so you can open the first one, assign compares, and you can read more about that. And here it is a way to browse a coherent set of misconceptions so that you don't get lost in the whole inventory, but you just can find the things you care about. So this is one first way to browse the catalog. The second one, if you are teaching with a textbooks and maybe I want to learn from you in the Q&A session about which textbooks are you using or which programming languages are you teaching. We have some initial support for browsing from textbooks. Now I have the overlay here of Zoom, so I can't really see what's going on. Let's see. Here we have textbooks, and we have index 2 Java textbooks. In particular, the most complete one is Objects First with Java, because it's the book we use to teach here at USI. You can click on the textbooks and you can see the chapters. So let's say that you are about to explain objects and classes, which is the first chapter. And you see that there are 2 documented misconceptions specifically for this chapter of this textbook, so that it's well known that sometimes textbooks contain some material that is somehow misleading for the students. So they use some sentences that are known to trigger in students a wrong understanding without the author's intention, but sometimes that's what happens. And so we actually documented the misconception we could find that are triggered by students reading this specific chapter of the textbook. So you could really be prepared in class the next week, for example, that your students might have these misconceptions that were induced by them reading a specific chapter of the textbook. We have indexed this book and another German book in Java. But if you want to contribute with misconceptions from one of the textbooks you use to teach, or if you have other ideas, we are definitely more than open. The third great way, I think, is to use what we call conceptual checks to navigate the misconceptions in ProgMisCon. So let me go back to the concepts page. So let's say that now you have these misconceptions about assignments in Java, and you don't want to read about all of them because maybe for a lot of them you think you know, or your TAs, if you teach in a university and you have teaching assistants, you think they know the stuff they are going to teach their students, but maybe they want to review their knowledge. They want to do a self-check. Now you can click here on the Check Yourself button, which is widespread throughout the website. And this configures a conceptual self-check for you. So this is in the language of Java about the concept assignment. And you have here a sort of quiz. So this is one funny or engaging way to interact with the material. This is really asking you questions. For example, we can try to do together the kind of first ones. You read and you say, well, in Java, is it that the equal operator compares to values, or is it that the equal operator assigns a value to a variable? And we can pick what we think is right. And so we can say, well, the equal operator, I think it assigns. And that's one way. And then we can also do another one. We can see, well, here I'm not really sure what's right. And then, I don't know, we can click another one. And for each one, after you have selected, you can uncover the mystery. You can solve it by saying, well, is this a correct conception? So this is shown in green, and you can still click Learn More to be directed to the relevant misconception. Or, well, in this case, where you selected, well, I'm not sure what's right, you have a potential misconception, and you can really click here. Or if you selected the wrong statement, you're brought with this red button directly to the misconception page. And so here you can read about this misconception that an assignment is not an expression in Java. And so you have like ways, and you can read about the correction. And so this is a funny way, for example, if you want to review and test your knowledge before you're teaching a specific concept in a specific language, this is one way to kind of narrow down the number of misconceptions you have to review. And yeah.
Luca, can I ask you one thing about this?
Sure.
Do you think that this quiz is something that teachers can share with their students as well? Or is it really aimed for the teachers?
Well, like in general, there is nothing that prevents students from doing this. The fact is that these statements, as I was trying to explain at the very beginning, are really written with precise and domain-specific terminology because they are really tightly close to the language specification. So in some cases, it might be that they use precise words and concepts that students do not really grasp, especially in introductory programming. But even like simple terms like, I don't know, variable, object, when you are into your first weeks of your first programming course, you might not really be sure about what is this idea of what a variable is. And so these very concise statements that really convey a lot of meaning in some short amount of words, they are often densely packed with meaning. And so it's often not easy for students. So the way we have primarily thought about these checks is for professors, teachers, and teaching assistants. So they're meant to be like for somebody who probably already knows the exact words and the exact meaning of those words, and it just wants to test his or her knowledge. And then, so this can serve as that purpose. So I would be careful in sharing this with students, even though there is nothing that absolutely prevents this from being done.
Thanks. Yeah, sounds clear. And I think it's also a great way, of course, to become aware of potential misconceptions.
Yeah, definitely. So these are kind of some of the ways. This is the summary of the talk I've been giving to Itixi. And yeah, I would be more than happy either to browse with you a little bit more the content or to hear from you about, for example, which textbooks you are using, which programming languages you are teaching, whether you think you saw misconceptions in past editions of your courses with your students. I think we can have a somewhat great discussion.
Thank you very much, Luca. In that case, I think if there's no more questions that have to be included in the recording, I think we'll wrap it up for the recording right now. Then I'll turn off the recording, and then we can have a discussion about this, and after that, a general Q&A also about CodeGrade if people have questions about that.